everybody, this is Miss Bufford. In this video, we're going to talk about the history of the development of the periodic table. So your learning goals are to be able to explain the roles of Mendeleev and Mosley in the development of the periodic table, and to be able to explain how physical and chemical properties played a role in the organization of the periodic table, and be able to explain why the periodic table is appropriately named. So when we're talking about the organization of the periodic table, one of the most important people that we can talk about is Dmitri Mendeleev, and he is known as the father of the periodic table. It's important to keep in mind a couple things when we're talking about this. First is that Mendeleev was not the only person in his time to attempt to organize the known elements, and he wasn't even the only person to attempt to organize them according to increasing atomic mass. But he did discover something that allowed him to do something with his periodic table that no one had been able to do, and that was he was able to make accurate predictions about the properties of elements that hadn't even been discovered yet. Another important thing to keep in mind is that during Mendeleev's time, the predominant theory, or the predominant atomic theory, was Dalton's model of the atom. And so remember that is that indivisible particle. We did not know about electrons. We didn't know about the nucleus of an atom. We thought atoms were just these solid spheres of matter that were indivisible. And so Mendeleev, when he began organizing his elements, he began ordering them according to their atomic masses. And so Mendeleev noticed that the elements, if he arranged them according to their atomic masses, they exhibit this apparent periodicity, or these repeating patterns of their properties. And this is how he discovered what's called the periodic law. And in Mendeleev's time, this law stated that when elements are arranged according to their increasing atomic mass, they exhibit a repeating pattern in their chemical and physical properties. And so this is where the name the periodic table comes from, is because of the periodic law. It's important to note that once atomic number was discovered, the wording of the periodic law was revised to say atomic number rather than atomic mass. All right, so if you take a look over here, this is an early version of Mendeleev's periodic table. And these numbers that are listed next to each element are their masses. They're not atomic numbers, because remember, Mendeleev didn't know about atomic number. He just had the masses and the data on the chemical and physical properties for all of these elements. And if you take a close look at it, you might see some familiar groupings of elements, even though, it's kind of flipped around in a different format than it is for us on our periodic table these days. But you'll notice that, we've got this group right here of these elements that have similar chemical behaviors. These are all of the alkali metals right here. And then we've got the halogens, where he's got them all grouped together, and, all these other chemical families that have similar behaviors. So you'll notice, some of the transition metals here. So it's organized very similarly to how we have it. We've, switched around the format a little bit, but this was how he decided to organize his periodic table. What he did notice, though, was there were a couple of elements that when he placed them in order of increasing atomic mass, they didn't quite fit into that pattern of properties that he had observed with the other elements. But he did realize that if he switched their places, they actually fit into that pattern of repeating chemical and physical properties much better than just using their atomic mass. And so it's important to note that Mendeleev, the main overall organization was the increasing atomic mass, but he did take into consideration chemical and physical properties, and he created groups on his periodic table where these elements that behaved similarly were grouped together, just kind of by stacking those repeating units. He also noticed gaps in his periodic table where no known element would fit, and this is what actually enabled him to be able to make the predictions about the existence of elements and what their chemical and physical properties would be like. So as some examples are, if you take a look over here at this purple box, these are the places for gallium, what we call gallium and germanium now, but Mendeleev called them eco-aluminum right here and ecosilicon. And because on our periodic table, they're directly below aluminum and silicon, and on his periodic table, they were directly after those two elements. but he called them ecoaluminum and ecosilicon because they're going to kind of echo the properties of those two elements. They're going to have similar chemical and physical properties. One thing that was really important for Mendeleev's table during his time was the discovery of gallium. And this element, was one of the ones that he predicted the existence of. And someone during his lifetime discovered the element and published a paper saying, I've discovered this cool element, brand new element. And Mendeleev saw this guy's data, was a German scientist, and he refuted it. And he was able to say that the scientist's data was incorrect and that the mass of this new element should be this. And he was actually correct in telling that guy that his calculations were wrong. And he had never even seen the element in person. He just looked at the data and the calculations and he said, nope, that's not the mass of your element. This is the mass of your element. And it really lent a lot of support to how he had organized the elements and how powerful this table could be as a predictive tool for that kind of thing. And so the next person that we're going to talk about is Henry Mosley. And he was actually a colleague of Rutherford's. And remember, Rutherford is the scientist who discovered the nucleus of the atom and proposed the nuclear model. So at this point, we know about electrons, we know about the nucleus of an atom, but we don't know much about the nucleus other than it's centrally located and it's got a positive charge. But we don't know how much positive charge. And so that's where Henry Mosley comes in. He used an X-ray tube to measure that amount of positive charge in the nucleus of an atom. And so he fired these high energy electrons at different samples of elements and found a relationship between the frequencies that were emitted by those atoms and their placement on the periodic table. And he realized that this relationship he discovered was the measure of the amount of positive charge in the nucleus of those atoms, and that it actually increased by one whole number unit with each successive element on the periodic table. And this was really important because this is a more fundamental way of describing the organization of the elements on the periodic table. And so he names this the atomic number. And we know that the atomic number is equal to the number of protons in the nucleus of an atom. And so with this discovery, Henry Mosley was able to use this to say that, or to confirm the ordering of the elements that didn't seem to follow that pattern. So remember that Mendeleev had switched cobalt and nickel on the periodic table. So they're not ordered according to their increasing atomic mass. Their ordering is more because of their chemical and physical properties. And Mendeleev had realized that he had to switch those. And Mosley was able to say, yes, Mendeleev was correct in switching the placement of these elements because their atomic masses are increasing, just as they should, the way that they're ordered. So good for Mendeleev. He also was able to predict the existence of 4 elements that has since been discovered. These are elements 43, 61, 72, and 75. Mosley was also able to confirm that there were only 92 elements between hydrogen and uranium. So exactly 92 elements there between those two elements. And he also said that there are going to be 14 rare earth elements. So he was able to tell us a lot about the periodic table and what elements might be missing, maybe what we haven't discovered yet, because he was able to measure this positive charge and realize that it increased by 1 unit with each successive element. Right? So hopefully this video was helpful. Let me know if you guys have any questions. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.